Okay, today's lesson, we're going to go back and review some factoring skills that we've learned back in Chapter 5 when we learned how to factor quadratic equations. Since we're now dealing with polynomials with various degrees and different types of polynomials, that we can still do some factoring, but we're going to have to learn some new patterns, and we're going to have to still use some of the old factoring skills that we learned when we were in the quadratic section. So just a quick glance at what we've learned in the past. You can see here the different types of factoring that we had. First and foremost, we're looking to factor out a common monomial. So you remember factoring out a common monomial. Then we just had our basic trinomials, and then you remember we had two patterns, a perfect square trinomial and a difference of squares. So you learn those patterns because we had perfect squares on either end. So those are still going to come into play here in this factoring lesson. We're just going to use these skills for higher degree polynomials. The first thing that we're going to look at is special patterns, but this time instead of dealing with perfect squares, we're going to be dealing with patterns for perfect cubes. So if you recall having to learn all of your cubes, so 2 cubed equals 8, 3 cubed equals 27, and things of that nature, those values are going to come in handy here as you learn how to break them apart. Very important that you remember those. It'll make this process go a lot quicker when you learn how to factor perfect cubes. Now, let's take a look at the two patterns. Excuse me. If you notice, in quadratics, when we had squares, we only had a difference of squares. Remember, we did not have any sum of square pattern, but in cubes, we actually have both. So we have a sum of cubes and we have a difference of cubes. Now, you need to pay real close attention that we have a perfect cube on the first value and we have a perfect cube on the second value, but the signs are very important. So if you look, if the sign in the first one is a plus, that means our first binomial is also going to have a plus. And then there's a negative as the first sign in the remaining trinomial. However, if our binomial is a negative, that means our first binomial term is going to be negative and the remaining terms in the trinomial are going to be positive. So what you'll need to do is you'll need to work a number of factoring problems with perfect cubes, and you'll need to just keep these patterns in front of you and work with them until you get accustomed to what they're doing and commit them to memory. So let's take a look at a couple samples here. If we look at example number 1, we can see part A, we have x to the third, which is a perfect cube, and we have 27, which we know is 3 to the third power. So we know 27 is also a perfect cube. Now, when we go to factor this, we need to keep our pattern in mind. I'll bring that back into the picture. So we have a to the cube, a cubed plus b cubed, so we have that here, and we can rewrite that in this form. So we'll have our first binomial should be positive, so it's going to be the a and the b value, which will be x and 3 in this case. And then the remaining part is going to be a trinomial, where we square on the front end and the back end, and then we just multiply the a and the b times each other. But since it was a positive binomial, that gives us a negative middle term. So that's a little different than maybe what you're accustomed to. So it's going to take a little practice getting comfortable with these cube patterns. Now, on part B, we have to do a little work before we get to a perfect cube. And as I've told you in the past, what you should always look for to start any problem factoring is there a common monomial that can be taken out. And in this case, we are dealing with 2u squared that we can factor out of the original problem. That leaves us 8u to the third minus 125, and so you have to look at that and you have to recall 8 is a perfect cubed, 125 is a perfect cubed, and if you remember your perfect cubes from earlier in the in the year, this will make this process a lot faster. Second thing you want to do is be sure that you look for a second level of factoring. So you can see here we factored once. So if we're factoring, we factored once here and then a second time here. So it requires two levels of factoring. First we had the common monomial, then we had to factor the perfect cube. So what you're going to find when we're factoring polynomials that have higher degrees than 2 is that a lot of times there's a second and maybe even a third level of factoring that has to take place. So you can't just stop after one level of factoring. Be sure to look for the second and possibly third level of factoring as we're doing this. Now, what I'd like you to do to the best of your ability at this point, and it's not gonna come easily the first couple times you do it, so it's going to take a lot more practice than these example problems. I'd like you to go ahead and stop the video and use the examples above and the patterns above to do sample problem number 1, part A and part B. So go ahead and stop that now and do the best you can on these two problems. Okay. Let's take a look at sample problem 1, part A. If you look at this, x to the third is clearly a perfect cube. But we're dealing with 125, and if you recall, 125 is the perfect cube of 5, so we can really rewrite this as x to the third plus 5 to the third. Now, as I'm working this problem, and I go back up to my perfect cubes, I know that I'm dealing with the sum of cube, so 8 to the third plus b to the third, and so I want to break that up, and I know that my first part of this is going to be a binomial with x plus 5. So I'm taking the x term and the 5 term and creating my binomial. And I know that's going to leave me a remaining trinomial. Now, the way that I like to do this that I think is easy is I know that it's going to leave me a squared term. If I have x to the third and I took out 1x, I know that that's going to leave me 2 remaining x's. If I had 5 to the third and I took out 1 5, I know that's going to leave me 2 remaining 5s. So those go on the front end and the back end, and I think that's a simple way to remember what you have left over. Now the middle term, a little bit more challenging. First and foremost, we've got to get our signs right. So the last sign is always a plus. In every perfect cube pattern, the last part is always plus. And then I know that I'm going to be multiplying the 5 and the x. The key here is recognizing that there's always a negative value somewhere in a perfect cube when you factor it. Whether it's in the first binomial or if it's in the trinomial, you should have a negative. So there's not going to be pluses all the way through. So I put my negative in the middle term. So now we just need to consolidate this a little bit. We need to clean up the squared terms. X squared is fine. Negative 5x is good. But 5 squared is 25, and that would be our final factored form. Now, let me point something out here. Do not make the mistake of this. You cannot break this up. This looks like a perfect square trinomial because you have a perfect square there and a perfect square there. But in a perfect square trinomial, what you should have is an a squared minus 2 times ab plus b squared. And notice this factor right here, negative 5x, does not fulfill the 2ab. It's just simply AB, and so you can see here if I erase that A out of there, that's what we have left over in the cube pattern, but a perfect square trinomial would be 2AB. So this is not a perfect square trinomial, so it cannot be factored any further here. So keep that in mind. This is not a perfect square trinomial. So very, very important that you understand that and that you don't try to factor that farther. Although I've warned you, we'll need to be factoring some parts down farther, a second or maybe even a third time. This is not one of those places. So let's look at part B. Part B gives us a polynomial with a degree of 4, but it also has a common monomial that we can pull out of there. So the first thing that we're going to want to do is pull out the a value. So I can factor out a common a, which gives me 64a to the third minus 27. Now, if we recall our perfect cubes, we know that 64 is a perfect cube and 27 is a perfect cube. So I want to go ahead and write it in its cube form, kind of like we did over here with 5 to the third. So I'm going to rewrite this. And so this is basically like saying 4a to the third power, and this is 3 to the third power. Now, if you do not need to do this step to kind of help you out, that's fine. If you can see how to break up the 64 and the 27, you're more than welcome to skip this step. I do this as a visual to help me know where everything needs to go. So I'll rewrite this, and I'm going to factor this perfect cube. Now notice it's a difference of cubes. So the negative is going to go with the binomial. So I take 4a minus 3. So I took the 4a, one of those, and one of the 3's, and use subtraction, which means that I have 2 4a's left. Now keep in mind, I'm going to use parentheses here so that I make sure that I square both the 4 and the a. I don't want to just square the a part. That also means that I have 2 3's left. And then I need to multiply the first term and the second term. So 3 times 4a is going to give me a 12a. And then I'll just need to clean this up a little bit. So I have 4a minus 3, and then that's going to give me 16a squared plus 12a plus 9. And again, 16a is a perfect square, 9 is a perfect square, but because the 12a does not fulfill the pattern for a perfect square trinomial, you cannot factor this any farther. So that is the final factored result of part B. Okay, good job.